The equation kx squared plus 4kx plus 3 equals 0, where k is a constant, has no real roots. I need to prove that k is greater than or equal to 0 and less than 3/4. So if this quadratic equation has no real roots, that's telling me that its discriminant, b squared minus 4ac, must be negative. So the b is 4k, the a is just k, and the c is 3. So b is 4k, the a is k, and the c is 3. 4k squared, 4k times 4k is 16k squared. And then we've got the 4 times k times 3, which is 12k. I'm going to divide through by 4 just to make these numbers a bit smaller. Then I notice that I can factorise k outside to get the roots of this quadratic. This k quadratic, the quadratic of this discriminant. So we've got 0 from here, and we've got 3/4 from here. So we can see that the graph of the discriminant would look like this. And the discriminant is less than 0 in between 0 and 3/4. So where k is less than 3/4 and greater than 0. There's one other thing I need to do though, just comparing my answer with what I needed to show. I need to talk about what about if k was 0. So if k were equal to 0, let's have a look at this equation. The first term, we'd have 0 times x squared, plus, then we'd have 4 times 0 times x, plus the 3, equals 0. Now the 0 times x squared is just going to be 0. The 4 times 0 times x is going to be 0. So on the left-hand side, I would be left just simply with 3. And 3 cannot be equal to 0. So if k was equal to 0, there would be no roots of this equation. So although that wasn't included in the discriminant, I do need to include it as part of my answer because there are no roots when k is equal to 0. So I do need the line underneath there as well to say that if k is greater than or equal to 0, then there are no real roots, as long as k is also less than 3/4.